Okay, so today we're going to talk about writing in point slope form given 2 points. And we have 2 points here, 517 and 1129. You can see the 5 is the x coordinate of that point, the y is the 17. So x is 5, y is 17, and our other point, the x is 11 and y is 29. I put those up there so we can continue to look at them as we get down to the next part. So in point slope, remember we want to have a point or points. In this case, we have two and a slope. And the first thing we need to find is the slope. Remember, to find slope, we do the change of y over change of x. And change means subtract, right? So we're going to look at our two y coordinates, which are the 17 and 29. And we're going to put those in the numerator on top, 17 minus 29 over or divided by our x's, 5 minus 7. And remember, if you start with the 17, you want to start with the 5. You want to start at the same location and go to the other one. 17 minus 29 is negative 12. On the bottom, 5 minus 11 is negative 6. And then we have to divide it. Negative 12 divided by negative 6 is positive 2. So now we can get into point slope form. Now that we have our slope and we have 2 points. Remember, point slope form is y minus y1, where y1 is the y part or the y coordinate of that point. M is the slope, and x1 is the x part of that point. So you can see here our slope that we calculated was 2, and now we can put in either one of those 2 points. Now we have both points here, so let's write these equations using both points. The first point, 517, so the 17 is the y. And remember, it's y minus whatever that y is. So y minus 17 equals, there's our slope, 2. And then in parentheses, we want to put x minus whatever the x is. The x is 5, so we put in 5. So for the point 517 that has a slope of 2, our point slope form is y minus 17 equals 2 times the quantity x minus 5. Now we can do the exact same thing with the other point. The other point is 1129. And you can see once again, we're going to put in our 29 where it belongs by the y minus 29, that's the y part. 2 is our slope, and then in parentheses, x minus the x part, which is 11. So two different, they look completely different, but I think you're going to notice something when we get to the next page. And that's this, the change to slope-intercept form. Let's see what happens. So we're going to change the first equation we came up with into slope-intercept form. Y minus 17 equals 2 times x minus 5 is what we wrote. And if we want to get y by itself, we're going to add 17 to both sides. And you can see that does get the y by itself. And we just have to clean this up by using the distributive property. So 2 times x is 2x minus 2 times 5 is 10. And we see we have a minus 10 and a plus 17. We can put those together. We can combine those like terms, and we end up with negative 7. So in slope-intercept form, that same equation is y equals 2x minus 7. Let's see what happens when we do it with the second point slope equation we came up with. Y minus 29 equals 2 times the quantity x minus 11. So once again, we're going to solve for y. So we can, or we're going to get y by itself. So we're going to add 29 to both sides, and that gets y by itself. And you can see we have everything on the other side. We added the 29. Now we're just going to distribute 2 times x minus 2 times 11, which gives us 22 plus 29. And we can simplify that into y equals 2x minus 7, the same equation that we got with the other point slope form. So what that really tells us, guys, is all three of those equations represent the exact same graph, the exact same line. Okay, so even though they look completely different, if we were to graph them, we would get the exact same line.